Hi everyone. Today we're going to be presenting our final project presentation for our deep learning course, ME297. My name is Turan, and my partner Zane. We're presenting this. Moving to the next slide. So this is about the visual identification of a variety of oranges. We're doing this to improve process efficiency in food factories. And we'll also believe that it could be used in supermarkets and stuff because there are different kinds of orange varieties and they cost slightly different, few cents, maybe 10, 15 cents a pound difference. And it's very important for a cashier to recognize the correct oranges so they can charge the customer accordingly. Otherwise, this can affect the business negatively in terms of losing the money. And so this work that we're doing is based on an existing classification model, which is based on the artificial neural network and particle swarm optimization. Our goal is to improve the accuracy, and we're employing convolution neural network to do this. Moving on to the next slide, just a little background on deep learning, a traditional approach that we're dealing with. The traditional approach is basically extracting features like edges, colors, and from the pictures using human methods and stuff like meta-heuristic algorithms, basically. So the accuracy depends directly on the human experience. While the deep learning, there's no need for feature engineering. We can just use the neural network and the layers that we come up with to do it for us. And this way, we can use neural network to achieve a very high accuracy without having any knowledge of like different types of oranges and stuff. Technical challenges that we have was data collection. The actual images that we collected are straight taken from the paper that we're using. They're publicly available. We had to process that data, and we also added a random square of mass, like black spots, big, huge black spots to create artificial occlusion. So this basically allows our model to be more robust. Let's say if the oranges are covered behind some branches or some kind of leaf or something, our model can still predict the right category of that orange. And also we have issues with the model setup. Determining the hyperparameters was a challenge, so we had to tweak and trial and error and come up with our correct parameters to achieve our desired accuracy. Also, using the TensorBoard, utilizing TensorBoard was also a little bit challenging, but we were able to do it with proper research and implementation. Some of the related work, this is from the paper that we're using. So they basically use the artificial network and different optimization techniques. The first one is the k-nearest neighbor technique. This is a simplest algorithm to implement solving classification problems. And the solution is basically determined by identifying the nearest neighbors to the query example and using those neighbors to determine the class of the query. Basically, different k-values are determined, and based on that, the nearest neighbor is identified, and the correct solution vector is also identified that way. So the existing paper was able to achieve about 71% of the accuracy in terms of predicting the correct oranges, which is not quite high. So they also employed two other techniques. The other one is the hybrid neural network with the artificial bee colony. This algorithm is based on the natural and social behavior of bee colonies. Basically, how the bee colony works. It has different types of bees. They have different types of responsibility. Like their types are employed bees, onlookers bees, and scout bees. Basically, they look for possible solutions, which is basically depicted in the form of food sources. The solution position is basically depicted in food sources. And these bees basically try to find the position of these food sources to identify the possible solutions. So it's based on the actual social behavior of animals, basically. In this case, it's the bee colony. And they were able to achieve quite a high classification accuracy, like 96.7. That's pretty good. The other one is the neural network used with harmony search. Basically, the concept is based on the improvisation process of musician in a band. So basically, only good improvised harmonies are kept and remembered by musicians till the better ones are found and replace the worst ones. So that's exactly what happens with finding the solution. And the solution is basically fed and optimized to the artificial neural network to correctly identify or predict the task that the model is made for. And so the accuracy that we achieved, or the author was able to achieve, is about 94.3%, which is still pretty high, but not the best accuracy. We wanted to beat these accuracies in terms of results, and that's why we employed our own method to do it. And on this slide, I'll hand over to Zhang. He'll take over from here.
Yeah, so as we know, we'll be using convolution neural network in analyzing and doing the trainings and developing the model. So for the design of experiments, we came up with 3 experiments. But before we get into the experiments and the methods, we will first have to resize our data to a standard size for the training. Know that we have a lot of these pictures coming with various sizes, and so we want to, one is to reduce the size of the image and to standardize the data input. So we decided to make all images to the 50 by 50 size. So in this slide, it's the first experiment. We first tried it with a grayscale. In traditional machine learning, data sets are converted to 2D arrays to minimize the resources needed for data processing. But this works great if we have images with different shapes. However, it's very difficult for us to pick up the orange characteristic as we're looking at spherical objects here. So as you can see, the epoch accuracy is not very high, and with a drop out rate of 0.2, the epoch accuracy rate is at around 0.35, which is equivalent to 35%. So knowing that, and if we go to the next slide, then we'll be able to see that. So here we have 3 images of the oranges, with 3 different types of oranges we're trying to analyze or classify. In here we've added the third dimension to the matrix, added the color. So we'll be using color image here, and that's a significant improvement on the accuracy by adding the color characteristic. By just looking at the appearance. And as you can see on the epoch accuracy, it almost got to 100%. On the graph, the accuracy that we were able to achieve was at about 98%. So with that validation rate of 20%, we got to 98% after 50 epochs. So I would say that's very good. However, we also want to simulate the real-life creations, the images. So by doing data augmentation, adding blocks to it, we put the next slide, and we'll see how we pre-process the images and by adding some of by blocking part of the images to force or to help the model to pick up imperfect objects. Now here, still with colored images, with the data augmentation. So we first generated the data, and then we put them through the training model. And as you can see on the graph, it yields a slightly better validation accuracy. What we're is something that we really trying to focus on is validation accuracy. It's not bad. It's at 97.9%, almost 98% after running 50 epochs. So what the benefits of this is we're able to recognize the classified objects, even the imperfect pictures. So it's getting into a more realistic situation.
Finally, the broader impact and the future work of our model. Basically, this can be implemented with actual hardware to improve process efficiency in the agricultural industry, and also it eliminates all the tedious tasks of food classification and can be fully automated. For our future work, we can say we can add expand our image database, put more variety of oranges, and improve the robustness. And also, we can further improve it by incorporating the recurrent neural network model as well. So that's it for us. Thank you for watching. Bye.